Yes, that's good to hear.
Yes.
So first of all, I would like to say that I recognize a lot of this context you are presenting in the start here about the importance of innovation and entrepreneurship for economic growth and regional development. It's very similar to the same discussions we have in Norway and in the EU. So it's very recognizable. I'm giving a presentation based on my discussions with Professor Elzo. We met in an ISPIN conference some months back and started discussing potential collaboration on how to teach innovation courses. So my presentation today is about how we can best balance the theoretic and practical part of innovation and how to actually do assessment of this. So you heard my background, so I will be very brief on that. These are some pictures of some of the products I've been working with before I started at the university. I've been working in the maritime industry for some years with product development on electronic products for fishery and also for tools for ROVs for subsea oil production. So I had quite a bit of engineering practice before I started my role in the university. In 2004, I started my academic trajectory at the university here in Norway. So as this picture shows, we are a distributed university on 8 campuses across the southern part of Norway. And we have different courses and faculties spread across these campuses. This is a picture of our rector, Petter Aasen, and as you see here, we have 4 faculties at the universities: Faculty of Health and Social Sciences, of Humanities, Sports and Educational Science. We have a School of Business, and we have the final faculty which I belong, which is the Faculty of Technology, Natural Sciences and Maritime Sciences. So in my faculty, we have 11 bachelor programs, 12 master programs, and 4 doctoral programs. So my belonging in here is at the Maritime Institute. So my teaching and research areas are connected to the maritime domain. It's quite a complex domain with a lot of different stakeholders and technologies and business concerns mixed into one another. And what is quite interesting these days is that this domain is very interested in digitalization, and it's a lot of innovation challenges and change challenges in this industry because of that. So my academic perspective on this is actually the combination of improvement and learning. I find that innovation and improvement and quality development are very closely related. And the role of learning is not central only for teaching, but also for innovation and improvement. So I find this overlap between learning and innovation a very interesting domain academically. I also think it's interesting to look at innovation, improvement and learning, both on an organizational level, but also on the individual level. So this is a bit reflected in my teaching approach as well. So if we move into the core question here, teaching innovation, how do we do it, what do we do, and so on. So I believe that you have about the same definitions of innovation as we have in the European countries. The Oslo Manual defines it as the implementation of a new or significantly improved product, service, or business process. And this is actually a quite wide definition. So we could argue that almost all improvement are innovation in some way, as long as it's taken into use. We see that innovation is spreading from technology into all areas of business and organizational life. And you might have been familiar with this presentation by Keeley. It's described in a book of 10 types of innovation from 2013, and is an example of how the idea of innovation is spreading as a sort of goal or process to improve all aspects of business life and maybe the life in society in general. So given that we are in an engineering setting, this is an engineering conference, and with my experience, I think the linkage between design and innovation is particularly interesting. As engineers, we have been training people for a long time to design products and systems that are hopefully usable. And when we are extending this into innovation, we need to be clear and understand what is the linkages and differences between design and innovation. So in one way it could be the same, but there are also differences. So with respect to the definition, in order to make something new or significantly improved, I think that's a design problem. So engineers contribute to innovation already by designing new products and services. The other part, innovation, is very often related to implementing, putting something into use. And I think this is the part where engineering might have not had a big role so far, but I understand that the ambition also in Brazil is to extend the understanding and role of the engineer to also go into implementation, how to understand the economic aspects and the market aspects and the challenges of putting products into the market. So in the design world, we have a lot of different methods and processes of how we do design work. And I think these are not that different from the methods and processes that we see in innovation literature, how to do innovation. So I think there are quite a bit of overlap, and it's quite good traditions in the design domain to build on when it comes to teaching innovation as well. The real world might not look as tidy as this, and there have been done studies on how innovation actually happens, and it's a lot more messy than these simple figures, as you certainly are all aware of. So this spaghetti model is probably more real life than these stylized models. So in one way, I think we should define design as something more technical, which addresses, of course, user needs, but it's related to producing new products and systems, and the technology and production concerns are a lot more central. On the other hand, innovation is more related to the business part of it, commercial issues, strategic concerns, the issue of management, and how to implement good ideas to create good economy in the other end. So the challenge here is to put design as a part of innovation and add on some additional teaching and curriculum to help students understand the economic part of it. So is innovation simply the implementation of a new design? That might be one way to look at it. And a question for curriculum design and in engineering education is, when do a design course actually turn into an innovation course? I see courses here in Norway that are called innovation courses, but are actually design courses, and vice versa. So during curriculum development, it might be a good idea to have a clear picture of what we're talking about here. When it comes to teaching, I think the challenge is quite similar. And what we do in Norway and with the people I've been talking and discussing design and innovation teaching with is that we teach students what to do, how to do it. And we teach them different process models. We teach them different methods and tools to be creative and to handle business model, the business model canvas and so on. And also a dash of project management. So I think this approach is quite similar from design teaching to innovation teaching. I guess you also might be familiar with this concept called 21st century skills, which is also quite high on the agenda in Norway. This is a set of skills that was developed by a group of companies some years ago. And I believe that these kind of skills are kind of the foundation for entrepreneurship and innovation. So this is not only about the commercial part, but it's also quite related to collaboration and communication skills, training people to be confident in groups and so on. So I think we can argue that maybe this should be in place before we train them too much in technical, entrepreneurial and innovation methods. So one challenge in the educational system is to ensure that these kind of skills are in place before we try to move too far into actual innovation. So what do we mean by theory versus practice? This is the discussion me and Elzo is currently trying to scope. And I think this model, it's called Kolb's cycle of experimental learning, is quite useful to discuss this. And Kolb argues that learning is a cycle that is going on almost continuously. That we do something, we have an experience, we hopefully reflect on it. And based on those reflections, we might draw some general guidelines or general knowledge that we can apply in other situations later. And once we understand how to generalize this knowledge, we can maybe plan to do things differently next time. And once we've planned and thinking about doing stuff the next time, we get new experiences and this cycle moves on. So with my perspective, I think the theoretical approach when we talk about teaching is where you start this cycle. Hopefully you succeed the students making this cycle, but you need to start somewhere. So I propose that the theoretical approach is that you start with the bottom step here, that you teach students about the existing knowledge and practices, learning from the experience of others. And this is what you find in the literature. You find best practices and experience from how other people have done innovation, done entrepreneurship and so on, and can use that as a basis for your own actions. The practical approach, you start in the same circle, but in a different stage. And this is where you actually start students by getting their own experiences. You don't provide them with a lot of input or a lot of theory on how they should do it, but you define it with a problem and they solve it and define the knowledge they need. Project-based or problem-based learning. This was mentioned in the introduction. So when I talk about practical and a theoretical approach, this is a sort of presentation of what I'm thinking about it. There is also another principle which I find is very useful in teaching in general, but might also be quite important to think about when it comes to entrepreneurial education. It's called constructive alignment from Biggs and Tang. It's described in a paper from 2007. And they emphasize that there needs to be good alignment between what we want the students to learn, how we teach them what we want them to learn, and how we assess. So finding this balance in entrepreneurship might be a bit tricky because we often emphasize a lot of motivation. We want to encourage people to try and do their best, but it's not that easy to assess a good effort unless we have clear learning outcomes. So this is maybe a challenge in entrepreneurial education that we need to discuss and be clear about. And the other trick here is that it's easy to assume that students learn what you want them to learn, but you don't know what they know until they show you. So this is another principle that might also cause a bit of challenge in entrepreneurial education, because there are so many different aspects we want them to learn. But how can we actually make them demonstrate all of this to us as teachers? So during assessment, we need to conduct both formative and summative assessment. So during our teaching, we need to ensure that they understand what we want them to understand, and summative, that we have exams to measure what they learned throughout the entire course. So Biggs and Tang, they also advise teachers to start with learning outcomes. And this is a model that I use and find very helpful also when it comes to innovation and entrepreneurial education. It's called Bloom's taxonomy, and the essence here is that you might have students obtaining knowledge and skills, but what do you want he or she to be able to do once she or she has that skill? So the big idea here is to actually use learning action verbs to formulate learning outcomes. Once you formulate learning outcomes as actions, it's possible for students to understand how to demonstrate their knowledge, and also possible for us as teachers to assess if they have the knowledge that we want them to have. And when we talk about innovation and entrepreneurship, it's also very tempting to jump right on creation. But in learning taxonomies, creation is argued to build on a set of competencies that is shaped like a pyramid, that you need to have some basic skills and understanding in the bottom, and then you can gradually move on to creating new ideas, new products, and new services. So it's the pyramid here, and using this pyramid when it comes to defining competences in innovation and entrepreneurship is something that I personally find very useful. So innovation certainly requires these higher thinking skills called HOTS, and the question is how can we provide these to students as much as we can. Innovation and I think also entrepreneurship should be viewed as a team sport. It's not a solo play. It might have been that in way back in history, but in modern society, it's very difficult to succeed in innovation or entrepreneurship as a solo player. So these are some examples of the players in the field of innovation. The inventor, the engineer, which traditionally have produced the technical solutions. The entrepreneur, who might have been most concerned with creating money from good ideas. And then also the manager, the orchestrator in large organizations or networks. This role has also been studied and emphasized as very important. So innovation skills, it becomes a kind of melting pot of different competencies. And in particular, when we think about innovation in all these different areas of business and social life, it becomes a very complex set of skills and competencies. So I believe that different educations should not try to do the same, but make each profession contribute in their own specialities, but still acknowledge that there are other specialties that needs to be in place. So I would like to continue with two examples from courses that I have been doing here at the university. I've had the pleasure to teach both engineering students and students in our master program for maritime management, and done two different approaches on this. So I'd like to exemplify this. So with engineers, I did a quite practical approach, which is a bit different from what I did with our management studies, where I'm using a more theoretical approach. So since we're talking about engineering, I would also like to mention that in Norway, the engineering educations are regulated by a national curriculum plan. So this was approved by the Ministry of Education and Research in 2011, and it contains a set of defined learning outcomes for all engineering education. So I've put forward one of them, which is related to innovation and entrepreneurship. And it's a goal for all engineers in Norway that they should be able to contribute to new thinking, innovation, and entrepreneurship by his or her participation in developing and realizing sustainable, socially beneficial products, systems, and solutions. So this has been a goal for engineers in Norway for quite some years now. So my first example on a practical approach to this learning cycle is a course I've had in our Bachelor in Engineering Product Design education. And the main learning outcome for this course was that students should be able to create and test a new mechanical product that meets defined technical and economic criteria. In hindsight, we could discuss, is this an innovation course or is it an engineering course? So there is economic aspects here, but I still think it's quite interesting to always reflect, is this innovation, is it entrepreneurship, or is it design engineering? So the teaching method was chosen because the practicality of the learning outcomes. This was quite a practical engineering course, so I also wanted a practical teaching method. I chose a problem, or sometimes called project-based learning, that I presented the students for a problem, and they needed to obtain the necessary knowledge to solve it. I wanted them to deliver an operational prototype of the product and the process to be documented in a project report. For assessment, I did something in this course I never tried before, and this was actually to do objective measurement of product performance as part of their final grade. So half of the grade was how well did the product function, and the other 50% was the quality of their work, which was presented in a project report. So the design problem was that they should design a 4-wheel cart that can transport 12 soda cans on a hard, even surface to a delivery point 10 meters away, using only the weight of the can as energy source. So basically, they were challenged to use the potential energy of 12 soda cans to make a cart that was propelling forwards using only gravity. So this was the technical part of it. And I organized the students as different companies competing with each other on finding the best product here. And in each group, one person was dedicated a project manager, one as a design responsible, one as an economy responsible, and one as a test responsible. So each group operated as a company, but I also gathered each representatives of each group into expert groups, which I supervised on their particular role in the project. And also each group was given some money to buy material and parts, which they needed to record in a cost sheet. So for final assessment, as I mentioned, half of the grade was based on the product performance. So I made a table like this, where they were able to score points based on the fastest delivery time, the lowest weight of the cart, the lowest cost, and the most precise delivery. So these are all measurables. So the cart that had the fastest time was awarded the best. The second best cart was awarded the second place, so on. So these points was calculated and were basis for half of the grade in the course. And the other part was based on a project report where they explained what they did and why they did it. So some experiences from this course design is that students, they were actually quite positive to a practical approach, and they also welcome this objective measurements as part of the grade. I was a bit excited about this because it might seem a bit harsh to do measurements as part of the grading, but it made sense to the students. Students also tended to take some shortcuts in methodology and use of knowledge, reflections and documentation, because they wanted to save time and get the job done. They focused a lot on the end result, and the quality of the process, in my view, suffered a bit on that. Students also became a bit tactical and prioritized one or two goals. They thought they had gained the most point by becoming the best on one or two criteria rather to do everything. And the learning cycle, it became quite long in this course. It started after summer, and the reflections on what they learned and what they could make out of this problem-based learning, it came later at the end of the exam. So the long learning cycle, in my experience, caused that they lost a lot of learning points because there was so much to reflect on in the end of the course. So one interesting discussion question from this is, can or maybe should a grade in practical design innovation be fully based on commercial or product performance? If no, why not shouldn't it? It's practical. But the question then is, does the end result actually demonstrate all the learning outcomes we want students to pick up during a course? So that was my first example, and let's move to the other one, which has a theoretical starting point. This is a course in innovation management for our students in Master in Maritime Management. So this is quite a different profession. We don't train students here to be engineers, but managers in maritime companies that operate ships, but also do improvement innovation in different areas. So the learning outcome in this course is to understand and apply the basic principles, tools, and concepts that can help in managing innovation. It's not a design course, and students don't have design competence or any engineering competence. So giving these students the task to design a product would require a lot of different skills than what they have. So the teaching method here is still student acted. I want students to not only listen to me lecturing, but do tasks as part of their learning. So at the start of the course, they get a lot of written assignments, and this will be the curriculum for them, all these assignments, solving them. The assessment methods chosen in this course is that I have presented and defined evaluation criteria together with the students, making an assessment rubric. The formative part is that Students present their work during class sessions, and we discuss what they understand, what they find difficult, and use that as a part of their learning process. And the final summative assessment is that they have a home exam where they need to submit some parts of the work that they have done during the course. So the assignment design is based on that there are 3 assignments addressing different parts of the curriculum or theory I want them to learn. And each of these 3 assignments have different parts that address different levels of abstract thinking. If you recall this pyramid called Bloom's taxonomy, I try to design my assignments that they address different levels of learning outcomes. So one part consists of basic theory questions where they are simply asked to explain some theory, tools, or basic concepts. And another part, they are asked to apply some of the methods. For example, they are asked to analyze a business case using the business model canvas, or do a QFD analysis, or use creative methods to generate some ideas, but they're not very big. It's quite small assignments, but they're just designed to make them train on using some particular methods. Another part is that they are to identify and discuss case studies and relate it to theory that they have in the course. Does it correspond to theory? Does it contrast theory? Or how does reality relate to theoretical concepts? And one part of their assignments is also to do peer reviews of the work of other students. So they are asked to evaluate the work of other students and provide the input on what is good and what can be improved. Because when I see that students are able to evaluate the work of others, that demonstrate quite a lot of learning outcomes. If they're only able to see it's good or not good, that tells me that they really don't know what to look for. And that is a good indicator of learning outcomes as well. Some experiences from this course design is that making assignments that actually are designed for different learning outcomes or different difficulty levels. It helps students prioritize and also make it easier to assess their work. Students are often familiar with how to demonstrate lower level learning outcomes, for example, explain theory, but it's much more challenging for them to demonstrate higher level thinking. For example, discuss what is the difference between design and innovation. That's just a random example. In order to explain similarities and differences, they need to be able to think in abstract ways. And for some students, it's they might be good practically, but it's harder for them to demonstrate this kind of abstract thinking. So it's important to have assignments that cover both practical and lower level thinking with abstract and higher level thinking. I think this approach also made it easier for me than the practical approach to provide a thorough and fair assessment of all the defined learning outcomes. Students were also, positive to this approach. They find that the tools and theories I present, they understand the use of it and how it can benefit them in future jobs. But it's also necessary to make sure that we provide some sort of exercises to help them in some sort of training on the theory or methods that we present in class. It doesn't need to be a big project, but some exercises to make sure they get some practical training. So to start concluding, how to balance this theory, practice, and assessment when teaching innovation and maybe also entrepreneurship. I think these three concepts or tools that I've presented have been very helpful for me. There is no certainly clear cut if one way is better than the other, but I think these tools help us understand what to do, how to balance it, and make clear to our student and ourselves what do we want them to learn in this course. Some final reflections and also claims for discussions or further research is that it's important to start with defining precise learning outcomes and teach according to them. It's also equally important to plan how to assess all these defined learning outcomes. If you find that it's difficult to assess some of your learning outcomes, it might be a good idea to revise them or potentially remove them. A practical training approach is better in some disciplines, including engineering, while a theoretical approach may be better in others, like management. It all depends how easy is it to simulate or arrange a practical setting that actually covers what you want them to learn. A very practical approach to innovation will often require resources that are outside the control of students or faculty. So this might provide the risk that students end in an unfair or vulnerable situations. Some students might get a lot of support from an external company, while others might not get it. How do you handle that in a fair way? It's possible and also beneficial to provide a combination of theory and practice in all kinds of courses. And there are many ways to provide practice. It doesn't always need to be on a very large scale. It can be, but doesn't always need to be. And in terms of making students aware of reflection and learning as they do work, I find it more useful to have shorter learning cycles where they reflect on particular issues more frequently, rather than having to reflect on everything at once at the end of the course. Because then they are kind of finished with everything and lose out a lot of learning opportunities that they could have. So that was my 40 minutes, I think. So I hope this was relevant and interesting for your seminar and your agenda on engineering and innovation and entrepreneurship. So if there is time for questions or interest for questions, I'm open for that.
Ok, quero agradecer mais uma vez ao Marius pela excelente apresentação e vamos abrir um espaço aqui para algumas perguntas. Nós temos alguns colegas que estão nos assistindo que têm algumas perguntas para o Marius. A primeira pergunta é do Ricardo.
Yes.
O Ricardo Luiz, ele é da Universidade Federal de Itajubá, e eu vou fazer a pergunta em português, e a tradutora vai fazer em inglês, vai traduzir. Quais são, na visão ímpar do professor, as implicações dos programas de aprendizagem baseados em desafios nas habilidades, competências empreendedoras e inovadoras, na mentalidade, nas intenções dos alunos, dos estudantes universitários? Se for possível, reforçar ou abordar esse tópico por meio de uma abordagem quantitativa ou prática, em contraste com a abordagem teórica qualitativa. Então, é uma pergunta, eu estou tentando reproduzir exatamente o que ele escreveu aqui. Por gentileza, professor Marius.
I think so. So in Norway, we also have programs called Young Entrepreneurship, where students are developing their own business idea and do marketing and some sales during only a year. And these programs are designed to train students in becoming innovators. And during university studies, we also offer these kind of courses. And I think that is corresponding to the practical approach in engineering, where we train students to design and develop products. So in Norway, there are reports that say that this is useful, but I have not seen any numbers on to what degree have this kind of training produced more entrepreneurs. So it would be an interesting study to see the correlation between entrepreneurship training and the number of entrepreneurs in business later on. So that is one role of training, is to produce more entrepreneurs. The other part is to train students that go into business and organizations to contribute to innovation, to be promoters and do their part and understand the importance of innovation. So you could discuss which is more effective, is to train people to think more innovation in their organization or business, or is it to train new entrepreneurs starting up entirely new business ventures? There are two approaches here, and I don't have numbers on how effective it is, but I believe in it, and the Norwegian government also has strong beliefs that this is working.
Ok, obrigado, professor Marius. Tem uma pergunta também do professor Jorge Cândido, da Universidade Tecnológica Federal do Paraná, e também o nosso vice-coordenador do grupo de trabalho. A pergunta é o seguinte: uma coisa que me chama a atenção, professor Marius, quantos alunos o professor tem? Pelo que vi, eram apenas 4 equipes. Como se faz? Ele quer saber, o senhor apresentou aí, tem 4 equipes, então quantos alunos envolve na sua classe? Pergunta dele: como se faz? Temos 40 alunos em uma sala e somente um professor. Aí ele completa: qual a necessidade de tempo para avaliação participativa para não ter uma avaliação superficial?
Yes, this is a very good question, because also in Norway, we are asked to do more thorough assessment, but also have more students. So it's a dilemma in the whole educational sector, I think. In my engineering course, I have about 20 students. So it's not a too big class. So I think it's quite easy for me to organize students in groups and supervise them in a good way. And I also think that having these objective measurement of product performance is students organize the test themselves, they do the measurements. So I kind of get that part of the assessment served from the students. When it comes to my management class, these students are about 40 students a year. It's a bigger class. So what I do there is to spend a lot of class time on discussing and assessing their work in plenary. So I use a method called flipped classroom, where students do most of their studies on their own, based on the assignments. And we spend most of the class time on assessing and discussing their work. So this method helps me give a lot of feedback on the student work without spending too much time outside the classes.
Ok. Obrigado mais uma vez. Só para complementar, que tem algumas perguntas, eu vou juntar, porque diz respeito a um tema único. Ainda na colocação, na pergunta do professor Jorge, ele diz o seguinte, se me permite, professora Sônia e professor Jorge, eu vou juntar, porque a sua pergunta, professora Sônia e professor Jorge, dizem respeito a um tema único. Na universidade pública ainda não existem tantos recursos aqui no Brasil. Gostaria de saber como há integração com o setor empresarial. E também a pergunta da professora Sônia, da Universidade de Brasília, ela diz que lá na UNB são 100 alunos por turma. Então, como desenvolver oficinas no sentido de desenvolver uma avaliação teórica e prática, né? Como fazer isso de uma forma equilibrada? Essa é a pergunta da professora Sônia. Por gentileza, professor Marius.
Yes, 100 students in class. Yes, how do you assess? I understand that is a big challenge, and this is where the theory of good pedagogy meets the sort of economic realities in teaching. So I don't have any good response to that. I certainly see the challenge. I don't know if you have been experimenting with peer reviews. That means that students are asked to assess each other's work individually or in groups. So this is a method that, to my experience, students learn a lot from it. Because once they need to evaluate something, they start asking questions about the quality of their own work as well. So I think the first step would be to train students to be able to evaluate the quality of their own work. If we're not able to train our students to do that, we need to do all the evaluation ourselves, and then we risk it being too superficial or shallow. So I try to spend a lot of time with my students to train them in being able to assess, and I define very precise evaluation criteria. I discuss with students, do you understand the evaluation criteria? Are there any criteria you think is missing or you find unreasonable? Is it easy here to separate which is good and which is not good? And I have this discussion with students in class because I want them to be able to evaluate their own work. And once they understand the evaluation criteria, things run a lot smoother. So that relieves a lot of feedback work from me because they start understanding what to look for themselves. So I think the larger the class, the more important it is to train students to be able to evaluate their own work as well.
Ok, nós vamos caminhar para o encerramento, mas eu tenho encerramento dessa sessão aqui da conferência com o professor Marius, mas tem uma pergunta aqui, essas são as duas últimas, ok? Uma é do professor Bonato, se não me engano, o professor Bonato da Universidade Federal de Itajubá, é isso, Bonato? Eu não tenho certeza. A pergunta é o seguinte, está em inglês aqui. Thanks for your presentation, sharing methods and experience. O Bonato da UNIFEI mesmo. Ok. Repetindo. Thanks for your presentation, sharing methods and experience. Balance is essential in everything in life, isn't it? I wonder how creativity can be set free to play a role in innovation. Please comment on that. Thanks a lot. Okay, Mario, please.
Yes, I think creativity might be a necessary ingredient in innovation. So what I do is to provide students with different creativity methods, and I give them tasks on how to apply these methods. So training them in creativity methods, it's maybe one way to set creativity free. But there are, of course, a lot of limitations as well, but I think creativity is necessary in innovation, and I hope that my teaching helps students become more creative.
Ok, a última pergunta, última pergunta eu que estou fazendo ao Marius. Lá no slide, Marius, que você comentou, você disse que esse programa de reestruturação lá na Noruega começou em 2011. Né? Aqui, as novas diretrizes curriculares de engenharia foram aprovadas pelo Conselho Nacional de Educação em janeiro de 2019 e aprovada pelo ministro, homologada pelo ministro da Educação em abril de 2019. É bem recente, são aproximadamente 3 anos. Então, você tem aí 2011 e 2019 a realidade do Brasil, 2011 a realidade da Noruega. Pergunta que eu faço é o seguinte: quais são os conselhos, né, que você daria para as instituições que estão nos assistindo, para os professores, os coordenadores que estão reestruturando seus projetos pedagógicos de engenharia para adequar às novas diretrizes curriculares de engenharia? Quais são os conselhos que você daria em relação a esse tempo, a esse período que vocês já estão na frente, no sentido de reestruturação dos projetos pedagógicos de engenharia? Por gentileza, por favor.
A good question, a big question as well. I think in engineering, the technical competence is still as important, or maybe more important than it was 10, 15, or 30 or 40 years ago. So I think engineering education needs to ensure the quality of the technical competence in education. And innovation and entrepreneurship and so on, it needs to be introduced, but not overtake too much of the technical part, because engineers will always be part of a team to produce good innovation. So if we lack the technical part, I think the whole innovation system will suffer. Engineers also maybe should be trained more to collaborate and understand the role of other professions, the role of marketing people, the role of managers, the role of all the different stakeholders in the innovation system, rather than trying to become and cover all of these roles themselves. So I think that's one of the experience and feedback also from companies in Norway. Make sure you keep good technical quality in engineering. And the other experience, it can be that when we revise engineering curriculum in Norway, companies are quite involved. They have a lot to say. And I think what has been lacking a bit in Norway is to also have pedagogues, teaching experts in the process. I think the engineers are confident in their own competence, but I think engineers should draw on pedagogical expert when they define curriculum as well. That is something we could have done better in Norway, I think.
Ok. Marius, eu confesso que vai ser a última pergunta mesmo aqui. Eu sei que nós estamos um pouco atrasados, mas eu não posso deixar de fazer essa pergunta porque é do nosso vice-presidente da BENJ, o professor Luiz Brandão, e do Instituto Militar de Engenharia também. Então, são várias perguntas conectadas em um eixo só. Eu vou tentar reproduzir aqui. Como o ensino de empreendedorismo perpassa todo o fluxo curricular na sua escola? Qual o planejamento? Quais as competências-alvo em cada fase do curso? Como isso é planejado? Existe planejamento de aumento do grau de competência e habilidades que devem ser atingidos no decorrer do curso? Big challenge, hein, Marius? Aí para você. Vamos lá. São algumas perguntas dentro do eixo de empreendedorismo e inovação. Por gentileza, se você puder nos ajudar.
Yes, again, very good questions. And I wish I had all the answers, but I also have many questions. But the way I've been thinking in my courses is that it's important that engineering students understand that technology is there to solve a problem, a need, and in one way make society better, or companies thrive in better ways. So I think it's most important to ensure that they have this understanding, and that they are motivated to think of technology not as a goal in itself, but only as a means. As engineers, we are only helping to solve problems that are defined in society. I think when we become technology pushers, when we are starting to be so fascinated by technology, we think it's a goal in itself. We are very far from an entrepreneurial or innovative approach. So we need to make sure that we understand that we are part of a system where we are helping to solve problems in society. So I think that is maybe the most important part in if you ask a general question across all engineering.